Good evening everybody and welcome to the CPD number 9. Today's topic is project design and variation by state. As you know, today's speaker is Mr. Gary Beamish. I will just give a brief introduction about Mr. Gary Beamish. Mr. Gary Beamish is a chartered civil engineer, chartered water and environmental manager and chartered environmentalist with 35 years of experience working extensively on a wide range of major capital, civil engineering, building and oil and gas sector in UK, in Oman, in Africa, in Qatar, in Asia, in UAE. He is extensively involved in feasibilities, detailed design, procurement, site supervision, program, contract administration, claim arbitrations for major infrastructure and residential hotel buildings. Having practiced in the private and public sector in senior positions as a consultant and contractor, Mr. Gary is specialized in the construction sector and within a number of related fields, namely commercial and contract management, arbitration, program and project management and project control, QA/QC and risk management. I welcome Mr. Gary J. Beamish on behalf of IIQS and giving your time for the CPD.
Thank you. Well, thank you very much, and once again, my apologies. I'm going to have to go micro-light to get around this place, that's for sure. Okay, project design and variations by stealth. Let's go straight in. Tonight's slides is going to comprise, there's only 7 sections, so hopefully it won't be that painful. Okay, introduction, there's some key questions and answers that we have to ask ourselves about design. System compatibility, that's about the systems and the design systems themselves. Design responsibility, design and variations by shop drawing, we'll come on to that, well, that's a biggie. And then we've got the contractor's mitigation and finally a conclusion. So, first of all, where we fit in. Right now, we're looking primarily at the design side of things as to what can and cannot be done. This is all about a design, bid, build concept. In other words, it's not a contractor design. The contractor takes the bid documents or the tender, tenders, and then constructs. So the employer has designed the work. So here we have the stages where we have the inception under the program management, the pre-construction, which is the design. Obviously we have the construction itself, and then post-construction, which is the defects period. Within any project, you have the same 4 phases, the inception, the design, construction, and defects. And as the expenditure from the employer goes out and gets more and more and more and more, it's in deficit. The payback return is when after the defects, when the place is in operation. So here you have a simple representation of, if you like, the bigger picture as to how the funding is required for a project. And here you've got the control and cost. At the inception and design stage, the employer's got quite a lot of control. But as that goes into construction, the engineer takes over and he has less and less control, right the way down through to the defects period where he loses control, but his costs all the time are rising. There was a report by E.C. Harris, who I'm sure you're all familiar with, entitled Global Construction Disputes 2012, heading in the right direction. Now, they highlighted the top 5 construction risks experienced by contractors in the whole of the Middle East region, not just the Gulf. These paramount risks have remained in their respective positions to date for the last 3 years and constitute an excellent starting point for what I'm going to go on to now. The 5 risks. There's a failure to properly administer the contract. Now this is on both sides, contractor and consultant, engineer and employer. Incomplete design information or incomplete employer's requirements. The first part of that, the incomplete design information, is the rogue. This is the one which causes the problem. Employer-imposed changes Well, you have recourse in the contract through variations, but it causes problems. Failure to make interim awards on extensions of time and associated compensation. There is reluctance in this part of the world for an engineer to make an award. Why? Who knows? It doesn't happen in the rest of the world. Unrealistic risk transfer from employers to contractors. The conditions of contract you have to put up with here are far more unbalanced. There's far more risk to the contractor, particularly in, for instance, the FIDIC Silverbook, which is the EPC, where the contractor design bids build, basically. And that is heavily, heavily weighted in the employer's favour. So, we have to look at some key questions now. And these were questions and answers for which Roger Knowles, who some of you may have heard of Knowles as a consultancy, construction and legal consultancy. Knowles Middle East used to be on the 21st floor here, on the API World Tower. And I spent about 5 years in that office with Roger. He came up with a lot of different questions and answers typically asked from industry professionals. And although he's got it in a book form, or several book forms, there are questions specifically relating to design, which I will come on to now. I'll just have a quick look at those questions to see what he says. Not wholly relevant to FIDIC and to the Gulf region, but the principle is very much the same. So, where is the distinction to be drawn between an architect engineer's duty to design the works and the contractor's or subcontractor's obligation to produce shop drawings? Any volunteers? You're waiting for the answer, aren't you? Okay. We'll try on the next question. Well, this is what Roger thinks. He says, it would seem that it is difficult to differentiate between design drawings and shop drawings. I have to take slight issue with that, but anyway, each case requires to be judged on its own merits. True. A reasonable interpretation is that the purpose of the shop or working drawings is to coordinate and or convert design information into a format to enable the materials to be manufactured and fixed. I put some comments in regarding FIDIC's definition later. The latter part of that I certainly agree with. Shop drawings are effectively coordination drawings. And again, we'll have a look at that. So where in a design build project there is a conflict between the employer's requirements and the contractor's proposal, which takes precedence? If there is any resultant additional cost, who pays, the employer or the contractor? As you'd expect, if the contract is silent as to which will take precedence, it is probable that a court would hold that the contractor's proposal takes precedence, and that it is commonplace for the contract to indicate that the employer has examined the contractor's proposals and is satisfied that they appear to meet the employer's requirements. And in that regard, the contractor's proposal takes first place. Some formats, such as the ICE, the Institution of Civil Engineers Design and Construct, and GCE, General Conditions Works /1 Design and Build contract, make it clear that the employer's requirements will take precedence over the contractor's proposals. Who is responsible for coordinating design? Can a main contractor be given this responsibility legitimately, even though he has no design responsibility? The lead consultant, architect or engineer will normally be responsible for design coordination, except where the contractor is appointed on a design, build or EPC basis. It is possible for an architect to word out the responsibility for design coordination in its conditions of engagement, i.e. its consultancy agreement with the employer, and thereafter put that burden in the contract documents and place it on the contractor's shoulders. It does happen, unfortunately. Can a contractor be held responsible for a design defect where the employer appoints an architect and no provision exists in the contract for the contractor to undertake any design responsibility? And Roger says, the employer engaged an architect who wrongly showed load-bearing walls as non-load-bearing walls on his drawings. Joe Canning, who was the builder, this is an illegal court case, accepted the information on face value and as a result did not provide adequate supports, which resulted in damage during demolition work. The court found that Joe Canning, the builder, was liable for 25%. This comes down to a duty of care. So there we have a division of responsibility. Can a main contractor be held responsible if a nominated subcontractor's design is defective? A long response. The main contractor will be responsible for design default in a nominated subcontractor's work if it is clearly stated to that effect in the main contract. In the absence of any express obligation, an employer would have to show such an obligation was implied. Very difficult to do. This may prove difficult if the subcontractor's design work was developed through a liaison between the subcontractor and the architect engineer directly. In other words, no involvement of the contractor. Particularly if it took place without him being involved. To protect itself against loss due to the subcontractor's design faults, it is always advisable for the employer to enter into a design warranty directly with the subcontractor who's going to be doing the design. Most of the commonly used standard forms of contract make it clear that the main contractor is not responsible for a nominated subcontractor or nominated suppliers' defective designs. And as we know, it generally tends to be the case where you don't have nominated subcontractors out here, or nominated suppliers even. They are named, and you are, as a contractor, you're told you have to take them on as domestic. That leaves a lot to be desired. Must a contractor notify an architect or engineer of defects in his design? Well, again, Roger quotes a particular case here to make his point. Although in the FIDICs, as you probably know, there are a lot of clauses, 1.8 and 1.9, whereby you have to notify of any defects that are known in your design and or in your works or documents that have been given to you. However, Roger holds to a point of law, which is the University of Glasgow and Whitfield and Lang. In the absence of express provisions, the contractor may have an implied duty to the employer to warn of design faults. In other words, it wasn't stated in the contract. Only where a special relationship exists between them. Otherwise, there would appear to be no obligation in the absence of an express term in the contract. The decision is difficult to comprehend in this case. If correct, a contractor could carry out construction work knowing of a design error, but without any obligation. It is hard to anticipate any subsequent cases following this decision. The decision in the equitable debenture case is to be preferred where it was held that an implied term exists in construction contracts that contractors should report design defects known to them, or indeed errors in the documents that they are given. So if an architect engineer acting as the employer's agent in the design-build contract approves the contractor's drawings and errors are subsequently found, can the architect or engineer be liable? This happens quite a lot. Roger's response: if the employer's agent approves contractor's drawings, it may have a liability. Most consultancy agreements require the consultant to exercise due skill and care in carrying out his duties, i.e. as the engineer. If due to a failure to exercise due skill and care, the error remained unnoticed, then the employer's agent may have a liability, whether or not it could have been discovered. The employer will have to demonstrate that the errors resulted in additional costs in order to claim damages. Where an architect or engineer includes a new product in its design following advice from a manufacturer, and the product proves to be unsuitable, is the architect and or the engineer liable to the employer for any losses? And Roger says, where an engineer architect includes a new product in his design, the employer should be informed at the outset. Failure to advise the employer would leave the engineer or architect exposed to a liability for negligence should the new product fail. Last one. Where an architect engineer approves or accepts a contractor's drawings, how long can this process take before an entitlement to an extension of time arises? Roger's response from a legal perspective is ideally the contract will indicate how long is provided for drawing approval. Most of them do. Or the contractor's programme should address the point. Again, it indicates when you're starting the work, so clearly you need to have the drawings a long time before that. If there is no provision in the contract, then it will be implied that a reasonable period is to be allowed. That's the legal perspective on it. Systems. When we look at the form of a design agreement between an employer and his consultant, you kick off with the report stage, which is your check on the site. You check the systems, liaise with the authorities, and prepare a design report, first and foremost. That's stage one. Then we have a pre-construction contract stage, and this is where you have the concept design being developed, you have a development of all the supporting data, and to develop all the information and documents into a bid for tender documents. When we look to move away from the design, heading towards the contract stage or supervision stage, it is then a need to prepare the further design and drawings. The engineer is then tasked with supervising the works and obviously assisting in settling disputes or making determinations, as the case may be. The preparation of further design and drawings can be an extremely contentious item, since the employer has a right to approve payment for additional services to a consultant, and may therefore refuse to fund further designs and drawings as being work already paid for, and this causes a dilemma. So the design's not being developed sufficiently, contract is starting, contractors on site, so I need more drawings. Who's going to pay for it? It's a dilemma. When you have a non-transit situation, there's a danger, and here is where the design consultant does not become the supervising engineer. So there's no link here directly. The danger that arises relates to the ownership of the design, both in terms of the manner of supervision and or inspection, and particularly with respect to those situations where the design may require change. So you may have a different engineer on site, you may have to refer it back to another party outside of the contract completely, because they carried out the design. And they are the ones, they are the architects of record. Design and supervision responsibilities. Very simple. To watch and supervise the works for specification compliance. To exercise skill, care and diligence. Exercise discretion fairly between the employer and the contractor. And they have liability for errors, omissions and negligence, depending on the circumstances. Employer's approval carries no absolution. In other words, it doesn't matter what the employer does at the end of the day, it's unlikely that the contractor is going to get any benefit from having something that's incorrect approved. Designer and or engineer to maintain their professional indemnity insurance cover throughout the period. And if we go to the next one, I think I might be able to do this, I'm not sure. Okay, I don't know if you can read that. This looks at the whole design, bid, build envelope. So employer design, contractor bids, contractor wins the contract, contractor builds. And we start off with the left-hand side, which is the integration of the design consultancy agreement between the designer, consultant, and the employer. There you have the report stage, pre-contract stage, and contract stage. From the pre-contract stage, you have this ever-developing loop in terms of information necessary. And that information goes first and foremost into the construction agreement, the contract, which is then verified, queried, and finally it gets built. So all of these issues of development feed back into the contract stage for final drawings, supervision, and of course potential settlement of disputes. Get back, okay. Design responsibility. There's really three areas here. There's the operational performance, the system orientation, and the scheme appearance. And if we look at the operational performance within your design, as a consultant, as an architect, as an engineer, you're looking at specifying things like the flow rate, temperature, pressure, velocity, acceleration, inputs, outputs, physical sizes, material specifications, system characteristics and attributes. That is your operational performance. That's the characteristic, that's where it fits in an envelope. Then you have the system orientation, how the components, subsystems and other elements should be geographically positioned or rooted or connected, supported, linked or otherwise integrated in order to produce the desired project output, performance or level of control within the planned confines of the overall design development. And finally, you have the scheme appearance, which is quite simply the aesthetics and the harmony as to how the design fits. Contractors' means and methods. Devise a means of supporting, connecting and spatially organising the design configuration envisaged by the design consultant. So this is the contractor's duty. He takes design responsibility for the suitability, strength and integrity of temporary works and or subsidiary elements where he may have designed. And he takes design responsibility for any specific items listed and agreed at the time of the tender. He has said, yes, I'll design that. For any contractor, for any submittal, material submittal, method statement, always prepare and submit a compliance checklist. When you submit something, you submit a drawing or you submit a material submittal, compliance checklist simply says specification, clause number, yes, it complies. Tick. Drawing number so-and-so shows where it is to fit. Tick. Yes, it complies. It's a compliance checklist. An employer or the engineer will take that first and foremost, your material submittal is there, they'll take your compliance checklist, and hopefully there's no deviations, and then they'll just say, okay, you're telling me it complies with the spec, it complies with the drawings, it complies with bill of quantities, complies with any other employer's requirements. Okay, thank you. Now I'll have a look. Much easier, much quicker. So, compliance checklist with every submittal. Very good practice. Design and process flow. Typical organisation and process flow. The overall project design should be, I might be able to get it up here if I can. Yeah, okay. I don't know if you can read that, can you? A little bit. I want to borrow those. Okay. MEP, this is mechanical, electrical, plumbing. Design and process flow. Oh, okay. Oh, that's actually, yeah, that was slightly better, I think. But, okay. So, we have the three parties basically. We have a design consultant, the engineer, and an MEP contractor in this case. And the design consultant on the right-hand side is project design, the project structure, the project architecture, fitness for purpose. We then have the MEP side, where the operational performance, the system orientation, and the scheme appearance, this is the MEP design by the consultant. This is his primary design. We then come down into the engineer's remit. And you can see the inspect and approve, supervising the works, revise and or control design drawings and other documents related to that, and review and approval of shop drawings, which may involve the request for information process and a cycle that goes on, a little mini cycle there that goes on. Within the contractor's design elements, there are the fabrication or manufacturing supports and connections, and there is the spatially integration of the MEP works into the built volume. So that's as far as the contractor's design goes. And once we get past that, it goes back through all the various systems like pipes, and we come down to the contractor's, or the bubble, which is the blue bubble, which is the entire contractor's MEP scope of work, where he procures it, he queries it, he develops the shop drawings if necessary, for integration and coordination purposes. He carries out the manufacturing and installation, systems checks, testing and commissioning, and then finally the as-built drawings and R&M manuals. So that's kind of a quick flash view of an MEP design and process flowchart. Time-lapse dangers. It may be that a considerable time elapses between the establishment of the primary design and its execution. Recently I know of a contract that was let 3 years after it was designed, and a lot of the very expensive plants and equipment was out of date, completely out of date, but the contract documents hadn't changed. Hence, when the contractor applies to begin the work via no objection process, it is possible that circumstances have changed. Indeed, it quite frequently does. In this event, the engineer should incorporate such changes into the primary design, but often chooses or is told to instruct the contractor to do all the changes, normally at zero cost. And this is where it gets contentious. So we have design and variations by shop drawings. Under normal and ideal circumstances, the designers, i.e. the employer's design drawings, are transmitted to the contractor in order that the contractor can apply its site expertise in producing shop or coordination drawings for his construction. These drawings are transmitted to the engineer for review, and they may be approved, they may be rejected in one form or another. The purpose of shop drawings. Now this comes from the FIDIC Risk Management Manual. I think it's 1997. And FIDIC themselves state, this is going to be a shocker, contractor is responsible for dimensions to be confirmed and correlated at the job site. Information that pertains solely to the fabrication process or to the means, methods, techniques, sequences and procedures of construction coordination of the work of all trades and for performing all work in a safe and satisfactory manner. Now I don't see design development in there in the slightest. We'll continue. Chapter 5 in the same FIDIC Risk Management Manual states part of the problem is that the parties to construction, i.e. the contractor, employer, designer, well, although the designer or engineer is not a party, but it is involved nonetheless. It was in the Industrial Revolution in the United Kingdom, in the latter or early part of the 18th century, where you had steam power was the name of the game, and you had trains being built, locomotives on massive scales, and you had different workshops all over the country producing and designing and producing various elements, all to go together, eventually to have to be fitted together and produce a working train. What happened was that each of these workshops produced their own designs. The person who receives all these bits of metal at the end of the day don't know how they fit together, don't know whether they're going to fit together. So he takes all the different workshop drawings and marries them all up to find out whether or not this guy's design for a spindle will fit the hole in the middle of the wheel. That's where shop drawings come from. Out here, crazy. Shop drawings for a sewer pipe or a surface water pipe. I forget the diameter, it doesn't really matter, about 1,000 diameter, 1,000 millimeters diameter, 3 meters down for 5 kilometers, a greenfield site, or in this case a brown sand site. And the engineer wanted shop drawings. Why? Tell me why. The engineer says, well, because there may be clashes along the route. Yes, there may be. So issue me a full construction drawing. No, that's your job, that's your shop drawing job. Wrong. If you haven't shown clashes or potential clashes on your design drawing, then they're not fit for purpose. If they're not fit for purpose, I'm going to claim if I hit something and you haven't shown it, and you know it's there. So, shop drawings. The only time, shop drawings, the terminology is wrong. They are coordination drawings, integration drawings. One of the only times you're ever going to find shop drawings for real is where you have different places manufacturing goods to be fitted together, and you have to look at those different design drawings. Integration and coordination drawings, not shop drawings, are what you have for this ceiling and everything that is contained within it. You have the luminaires that protrude into the ceiling. You have the air conditioning ducts. You have the firefighting